Okay, the second half of the completing the square video. Now that you know how to complete a square, we're going to look at how to factorize quadratics using the completing the square method along with the difference of perfect squares method. So looking at this expression here, the first one there, x squared plus 8x minus 3, if you went through the process, you can't see any highest common factors. It's not a difference of perfect squares, and it is not, it cannot be factorized by trinomial method. So there's no factors of -3 that multiply, that add together to get positive 8. So in that case, we might have to complete the square. Now, this has already got 3 terms in it, so this is not a square term, okay, but we can make it into a square term by completing the square. So what we're going to do, first of all, we're going to give ourselves a little bit of room. Okay, so 8x squared plus 8x. Now, we're going to put an extra term in here, and then we're going to put an extra term in here, and we're going to have our, so what I've done is I've moved the last term, or c, all the way out of the way, and we're going to create a perfect square, and then we're going to factorize it. Okay, so what we have to do now is find out what term goes in here to complete the square. Okay, so forget about this stuff at the moment. All we're trying to do is find a square expression or a perfect square expression, because as you should be hopefully aware of, we can easily factorize square expressions, and I'll show you what that means in a minute. So remember what we did to complete the square. We halved 8, so 8 divided by 2. Oops, I'll put it in. So 8 divided by 2, and we squared all that to get the last term. So x squared plus, now 8x, that stays the same. Now 8 divided by 2 is 4, 4 squared is 16. Okay, so that gives us a square expression. Now, just what the reason why we, so I'll put that down there, and I'll bring this stuff down too, I'll put it in red. Okay, because this stuff still exists, we can't forget about it. All we've done, we've moved it out of the way. Okay, so we can't change anything in expression, but we can move things around according to the rules of mathematics. So to keep this exactly the same, if we've added 16, okay, because we added 16 here, this wasn't part of our original expression, we have to take it away again. Okay, so what we do is we just simply take away 16. We bring down the -3 as well. Okay, so now the next step in this is to factorize, and I'll write this over here. Okay, factorize, okay, a perfect square. Okay, not a difference of perfect squares yet, a perfect square, and you should recognize this, hopefully, as a square trinomial. Okay, so if you thought about just this bit here, you thought about factors of 16 that add up to 8, and you should find that that will be, so 4 and 4, okay, because it's a perfect square. So we've actually completed the square. So this is going to be this, okay. Hopefully you've done enough of those to recognize how to do that, okay. The other thing we can do at the end here, we've got -16 and -3, and we add those together. Okay, so -16 minus 3 is -19. Okay, so we've factorized a perfect square, and we've collected like terms together. So in the next step, we can make this into a square number, x plus 4 all squared minus 19. Now this is where our difference of perfect squares comes in. Okay, so now if you have a look at that carefully, we've got a square number here. This is a square number. This is not quite a square number, but we can make it one, because we can say the square root of 19 squared is a difference of 2 squares. Whoops, is a difference of 2 squares. So now we're going to factorize a DOPS. Okay, now if you remember correctly, a difference of perfect squares is this number squared minus this number squared times this number squared plus this number squared. So x plus 4 minus square root of 19 x plus 4 plus square root of 19. Okay, so that is actually now fully factorized. That's the answer to that question. Okay, so that is how you factorize some quadratics when you sometimes can't do the other methods. Okay, so this method's a good the next step. Okay, just one thing about these. Sometimes when you get to this step here, okay, so you cannot always, I'll write this out, okay, you sometimes cannot factorize difference of perfect squares. And the reason for that is if you have a plus there, okay, it's not a difference of perfect squares. All right, so some of these actually don't. So for example, this is an example, e.g., if you had the x plus 4 all squared plus the square root of 19, for example, squared, this plus here makes it not factorizable. Okay, so that means cannot be factorized, and that's where you'd stop. In this case, you'd do this. Okay, cannot be factorized. Okay, now there's a good reason why that cannot be factorized. We'll go into that more when we do parabolas. When you graph these things, they become parabolas. I won't complicate it by going into it now, but not being able to be factorized has a specific meaning for these examples. Okay, so let's go back up and we'll do the next one. So we've got x plus 2 minus 2x plus 8. So again, you'd exhaust all. I know this one does not, there's no factors of 8 that add up to -2, so I can't use the trinomial method. But what I'm going to do is I'm going to use my completing the square method. So x squared minus 2x, leave a space and another space, and then you add 8 onto the end. Okay, so we're going to work out this number first, and we're going to take it away, okay, to make a perfect square. All right, the only way we can factorize this is if we make this into a perfect square. All right, so what we're thinking of is numbers, we half -2 divided by 2 all squared to get this bit here. So x squared minus 2x. Now -2 divided by 2 is -1. -1 all squared is +1. Okay, so we have to take away 1, all right, because we have to even it up, and we add 8 onto the end here. Okay, so this bit here is now factorizable by perfect square method. Okay, so factors of 1 that add up to -2 are going to be x minus 1, x minus 1, okay, and -1 plus 8 is going to be +7. And you might already be able to see that even though this is a square number, the second one is not. Okay, so just as I mentioned before, okay, we've gone through our factorizing perfect squares, completing the square. Okay, and the thing to notice is this is not a difference of two squares. Okay, not a DOPS. Okay, this expression cannot be factorized. Okay, so we can't solve this. Now, what that actually means, I will go into it because I've got a little bit of time. When you eventually get to graphing these things, okay, when you factorize these things, well, I think this is in the next chapter. These answers down here, so these actually end up being when you equate them to 0, they end up being the x-intercepts. Okay, so for example, that first one, you might get a parabola that goes like this. Okay, and these would be the x-intercepts here and here. Okay, so some parabolas have 2 x-intercepts. Some parabolas have 1. This comes down and touches the x-axis like that. It's got 1 x-intercept. Now some don't have any. If there's a parabola up here, okay, it's above the x-axis, it doesn't have any x-intercepts, and that's what's actually happened in this example here. So for a question like this, it can be graphed, it just doesn't go over the x-axis. Okay, so that's how you complete the square. Don't worry about this graphing stuff too much. Just be aware that not all these expressions can be factorized. Okay, do some questions. Good luck.